So one of the strategies that we talked about was, that I talked about in the very first part of this problem, was setting up a system of equations. So I want to talk you through how to do that a little more carefully here. So we have 2 points of data. We have 21,200 and 23,392. And again, that's coming straight from the problem we were just doing. I'm just going to show you another way we can do this. We can end up with 2 equations in terms of A and B. Now, what we're saying here is that we don't know the value on day 0. So we're probably going to get a different equation than we got in our first problem, but it would just be, and I mentioned this in the development of that first equation, it's just calling day 0 something else. So as long as we know what day 0 represents, we're good. This is taking the dates in March and using them as your X values. Okay, so if we were just trying to find an equation for this problem, we could do, so Y, I'm going to write my 2 points out here a little bit better. So we have, call this X1 and Y1, X2 and Y2, just so we can differentiate. We have our equation, Y equals AB times X. And I'm going to go ahead and plug in 200 for Y, and X is 21, and then 392 for Y, and X is 23. Now you're going to notice I'm going to write them in the opposite order, and I will explain why in just a moment. So 200 equals A times B to the 21st power, and then 392 equals A times B to the 23rd power. When we're solving a system of equations that's exponential, there's a couple ways you could do it. You could solve for A, and then plug that into the other equation. Or my preferred method is to use elimination. So just like we do with regular system of equations, we can in some way combine the 2 equations and eliminate one variable. And the way I'm going to do that is by dividing these 2 equations. So if I divide 392 by 200, I believe we get 1.96 equals A divided by A is going to be a giant 1. And then B to the 23rd divided by B to the 21st, that's just going to be B squared. We subtract those exponents. And then this should look really familiar. We get B equals 1.4. Now we can use that to find A. So now that I know what B is, I can rewrite the equations, one of them. I'll write the second one here. So let me just differentiate what we're doing. We found B, let's find A. So 200 is our Y value equals, now I know what B is to the 21st power. So now I just have to solve that equation for A. Now, while finding 1.4 to the 21st power isn't exactly, friendly, you have your calculator that can do that for you. So we would do 1.4 to the 21st power, and we get some really large number, and then we're going to divide 200 by that. And I think it's like 1171 or something is what you get when you do B to the 1.4 to the 21st power. And when you divide 200 by that, I'm just not showing all of that work here. We get A is approximately, it's like 0.1707, okay? So I could then write my equation as Y equals 0.1707 times my multiplier, which is 1.4, to the X value. Now you'll notice this is similar to the equation that we wrote, same multiplier. However, we have a different 0 value. And our zero value this time is going to actually be the last day of February, whatever that date was, because that would be day 0. Since day 1 is March 1st, since we used the date in March as our X value. Okay. Same process, just different start value. Most of the time you're going to be a little more sure about what your start values are. This one's just a little strange.